The inverse sine, cosine, and tangent functions. Now what we need to do first is talk about inverse functions from algebra. First thing we need to check is if they're one-to-one. What that means, if they're one-to-one, they pass the horizontal line test. So for example, if you have something like this, like a parabola, that is not one-to-one because it doesn't pass the horizontal line test. Because anytime I draw a horizontal line through it, or as long as I draw a horizontal line through it someplace and it goes through it more than once, it does not pass the horizontal line test. Here's what you can do though. I can take that same graph that I had and I can restrict the domain. For example, there. Here the domain was negative infinity to positive infinity. Here I restricted it from 0 to infinity. And now it does pass the horizontal line test, which does mean it is one-to-one. So that's what we're going to do with our trig functions. Now there's some things you need to be aware of. First off is the notation. Anytime you see the f -1, that does refer to inverse. And so an inverse of its function pretty much undoes itself and it equals the x if the x is in the domain of f of x. And the domain, if you look at it, is for f of x, which is the inside function. And so for this example, or this notation, the f and the f inverse undo each other, leaving the x, but notice that the x is in the domain of the inverse because that's the inside function. And something else, the domain of f of x is the same as the range of its inverse, and the range of f is the domain of its inverse. And then they're both symmetrical by the line y equals x. And the way we're going to find inverses, or what we did in algebra class, is we replace the f of x with a y, then we interchange the x and y, and we solve for y, and then we go back to our inverse notation. But the main thing is the interchange and then solve for y. So now let's look at some trig, the inverse sine function. Now this is the graph of sine, and as you can tell, it does not pass the horizontal line test. Got that? So what we're going to do, we're going to restrict it. And so it's understood that we're going to restrict it from negative pi halves to pi halves, which means we're not looking at that, and we're not looking at that. We're only looking at it from there to there. So that does pass the horizontal line test. And so, once again, this is sine x, y equals sine x. So the domain is now, we're going to restrict it to negative pi halves to pi halves. If we didn't restrict it, it would not have an inverse. That's why we have to restrict it. And the range still goes from -1 to 1. Inclusive. Those are included. -1 to 1. And this is actually going to be a pretty big deal. Now, once again, if you wanted to follow the steps to find the inverses, we would replace the f of x with the y, interchange x and the y, and then we would solve for y. And what results is a brand new notation, sine inverse. And if you look at your calculator, you'll see it above the sine key. So be aware it does exist on your calculator. Now, when we did the graph of our sine function, the x values were actually angles, or thetas. And then the y value were the ratios, or the trig values. Some people call them ratios, so just call them ratios. But for sine, or for inverse sine, everything changes. So let's just look at this for a second. For inverse sine, in fact, let's just do this. Let's just do this. For y equals sine x, we have the domain, we restricted it from negative pi halves to pi halves, make it 1 to 1, and the range is negative 1 to 1. That's what I have up here. Now for, well, let's just even make it even better. Let's just use the correct notation so you don't know exactly what I'm looking at. Then for the inverse of x, which we'll call inverse sine of x, the domain flips, becomes negative 1 to 1, and the range becomes negative pi halves to pi halves. And once again, the domain was our angles, and the range was our ratios. Down here, the range becomes the angles. That's the wrong Greek letter. Their angles are theta, and then the domain is the ratios. And that's what this says. The domain is the ratio, while the range is the angle. Sometimes if you see the domain and range, how they actually look, you'll start recognizing pi halves, which are in radians. Now, when we find values for the inverse sine, we're actually going to be looking for angle measures. The x, it's like this. This f inverse of x, this inverse sine, is nothing but a y value, and the y values are the ranges. So when you're asked to find inverse sine of x, well, x is going to be one of these ratios between negative 1 and 1, and the answer, the y value, is in the range, which means it's an angle measure. So the sine will result, inverse sine answer will result in an angle. So for example, let's find the exact value, and once again, we always have to keep this in mind. Well, we're only looking between negative pi halves and pi halves. That's what our angles are going to be. In other words, it's the fourth quadrant and the first quadrant. This is your x, and this is your y-axis. Just keep that in mind. I'll do some examples to better explain it. Suppose you have y equals inverse sine of 1/2. Now if you want to, you can take the sine of both sides or rewrite it using sine of y. There's all kinds of ways of doing it. We can do it as an equation like this, like we've done here. And what it ends up being though is that this y value is the angle for which sine equals 1/2. For which sine equals 1/2. And when does sine equal 1/2? When you have a 30-degree angle, because sine is the y value, which is, or pi 6, or 5 pi 6, or 150 degrees. Or else does it equal positive 1/2? Because that's a negative 1/2, and that's a negative 1/2. So it could either be pi 6 or 5 pi 6. But remember what I said, we've restricted the domain from negative pi halves to pi halves. And in case you don't remember, negative pi halves is going this direction, so this is the same as negative pi halves. So negative pi halves to pi halves. I'll write it here, make it a little bit easier to see. So negative pi halves to pi halves. The only value it could be is this pi 6 angle, or 30 degrees, however you want to look at it. Because negative pi halves, well, it's negative. We want the positive. And that's what all this information is saying. I think I said pi halves, didn't I? It's pi 6. Pi 6 is where sine equals 1/2. Positive. Let's do some more examples where they're not laid out for you, where you got to think of them. So in this example, find the exact value of inverse sine of 0. Now what this is asking, it's asking for the angle between negative pi halves. I just use the interval, so you know it also includes those, such that sine of theta equals 0. And we're doing radians. So this is what it's asking. And so what is the angle between negative pi halves and pi halves such that sine theta equals 0? And if you look at your unit circle, or if you already know of your unit circle, sine is the y values. The only place where that's true is at 0. So the answer is 0. 0 radians. And not 0 degrees. I'm doing, since that's 0, I'm going to do it in radians. I could do it in degrees, but I'm just going to keep it in radians. Most things are now going to be in radians. Let's do this example. Find the exact value of inverse sine square root 2 over 2. And once again, that is the angle it's all about the domain restriction. In second power 2, comma power 2. I said second. Why am I doing second? Negative power 2, comma power 2, such that sine of theta equals square root of 2 over 2. Hopefully you know by now square root 2 over 2, that's a 45-degree angle, or pi force. And if you look at your unit circle, pi force is there, and negative pi force is down there. We're only looking at these two quadrants. But this is a negative, and we want the positive because our given ratio is positive. So that answer is pi over 4, or 45 degrees. Now we're going to do some more examples. You should be aware, and I've already mentioned this, that not everything is nice. Not everything can be used or found on a unit circle. So we do have our calculator. And we're going to use our calculator to show you how to do these ones I just did, because we know what those equal. And so let's go to the calculator. And I've already mentioned there is an inverse sine. It's above the sine key. So let's go ahead and do inverse sine. So just make sure their mode, we're going to keep it in radians. I may switch it to degrees on some of these. But for the most part, if we're in radians, or if we want the answer in radians, I should say, we're going to keep our calculator in radian mode. So let's just find inverse sine. That means you hit inverse sine, or second sine, brings up the inverse key, inverse sine key, 0, enter. And you see the 0. Now I'm going to do inverse sine again as square root 2 over 2. Make sure you close that parentheses. Then close that one. Well, make sure you put the 2 in. It always helps, doesn't it? Enter. And you get that. Well, maybe you remember this, maybe you don't. I'm just going to show you something. It doesn't say to approximate, it says find the exact. And so we're looking for answers in terms of pi because we're in radian mode. You can do this if it's divided by second pi, second caret key, and then hit math, enter. Convert that to 1/4, just put the pi on top. But I think there's a better way to do that. And that's to go to the degree mode, which I very much prefer. I prefer to do everything in degrees, to be honest about it. So now I'm going to type in inverse sine, second square root of 2, close it, divided by 2, close it, enter, 45 degrees, and then go to my unit circle, or just remember that that's same as multiplying by 180, or pi over 180. and you get the pi fourths that way, but just look at the unit circle. You see pi fourths the same, or 45 degrees the same as pi fourths. But what I really would do, myself, would think 45 degrees, and I would do this. And 45 goes 184 times. Leaving us with pi over 4. That's what I really would do. Especially if I don't have a calculator that would do things for me. Now, let's do this example. This is not a special ratio. This is an ugly one. So what I'm going to do is I'm going to put it back in radian mode. And it mentioned, or the problem states, around to 2 decimal places. And that's what I'm going to do. I'm going to keep my answer in terms of radians. So I just hit second sine for the inverse, negative second square root of 2 divided by 3, close it, enter. And our answer is negative 0. I sit around the 2 decimal places, 49. And that's the answer in degrees, or radians. That's not so bad. Now, as previously mentioned, the inverse sine undoes the sine function, the sine function undoes the inverse sine. So you may start seeing this kind of notation. Sine inverse of sine x. That can equal x. And sine of sine inverse of x can equal x. Not always. You need to be aware of that. And the reason why is because we have to look at our domains. Remember our domain? We have to look at the domain of the inside function. The domain of sine x. When we restrict it, do you remember how we restricted it? It's up here. From negative pi halves to pi halves. And then for invert, or f, or sine inverse, if it was from negative 1 to 1. So this is only true on the domain negative pi halves to pi halves. And this is only true from negative 1 to 1. So how about the domain and range? Just remember, almost every one of these, except for cosine and cosecant, or secant, cosine and secant, would be negative pi halves to pi halves. Tangent, cotangent, the negative pi halves and pi halves will not be included because they don't exist. And plus, you can look at your calculator, you can look at your graph on your calculator and see that also, or use your unit circle. So in this example, we're actually looking at sine inverse of sine 4 pi over 5. Now 4 pi over 5 is not a special angle, but I'm going to show you how you can find it. And if you think about a unit circle, over here we have pi. Now pi is the same as 5 pi over 5. And we want 4 pi over 5, which is just 1 less than that. Because 5 minus 1 pi is 4 pi. So that puts it over here. This is 4 pi, or 4 pi fifths, which is in the second quadrant. But remember, when we were using sine inverse of sine, we have to be from negative pi halves to pi halves, which is from there to there. Got that? So what that means is we can use a reference angle. Pi halves, we have a pi halves here, we have a pi halves down here. Well, since this is a positive, I kept saying pi halves, it's 4 pi fifths, or pi fifths. Well, this is 4 pi fifths, and this part is pi fifths, since we're using a reference angle. Which means we have a pi fifths here, and a pi fifths here. But this one, since sine is negative down here, we don't use that one, because we want the positive one. Because sine is positive in the second quadrant, so we have to use where it's positive, and that's also in the first quadrant. So therefore, sine inverse of sine 4 pi over 5 is equal to pi fifths. Let's do another one. Maybe I did a better job of explaining this one. I think it's easier to explain it when you're actually starting from scratch than it is when it's already worked out for you. So here we go. Find the exact value of sine inverse of sine 9 pi over 8. Now that 9 pi over 8, if you think about it, and I do like to draw the pictures, we never need it. This is the same as pi, and I know that that's the same as 8 pi over 8. Now 9 pi over 8 is 1 pi over 8 less. We can just think about it. If I have 8 pi 8s, I need one more to make 9 pi 8s. And so that means that in here we have pi 8s as a reference angle. And in all actuality, since it's down here, it's actually a negative, but we only want to look at the pi 8s. Since we're restricted from negative pi halves to pi halves, we have to look either here or here. So, yes, this is a negative pi 8. Got that? And we do need to look at that. Where else do we have a negative pi 8? We can look in the first quadrant or the fourth quadrant, because that's from negative pi halves to pi halves. Here, this would be positive pi 8, but we want a negative pi 8 because 9 pi 8 is down here, and that's where and sine is negative down there, so we need where sine is negative, and that's over here. So that's negative pi 8. So here's the moral of the story. We use this information to find the reference angle, and then we use these two quadrants to determine what's going to be our value. And the reason is because we only look from negative pi halves to pi halves. So the answer is negative pi 8. It has to be either a fourth or first or fourth quadrant angle. Now let's look at this one. This one's a little bit back. This one's backwards. We're doing sine of sine inverse of 9 pi 8. This one, I'm done. It does not exist. And the reason why it doesn't exist is just look at 9 pi 8. 9 pi 8, if you just type that in your calculator, you get an answer that's 3.53, which is way bigger than 1. Because you remember our domain restrictions? Inverse sine has their domain has to be negative 1 to 1, or x value does. And that's what that's saying. You can't find inverse sine of 9 pi eighths. It doesn't exist. So there's no solution here. There's no value here. It's different than this one. Because on sine of 9 pi eighths, we could actually find that value. And then find inverse sine of that. The sine of that value, we can always use the reference angle. Because we can restrict it from negative pi halves to pi halves. But when it comes to inverse sine, we can't use reference angles because this inverse sine is actually asking for the angle right now. But it has to be a value between negative 1 and 1 for us to find that in between the first and fourth quadrants. Or in the first or fourth quadrant. There's no value. Because we're going to look at a number bigger than 1. Or we can't look at a number bigger than 1. And furthermore, we can always use our calculator to help us out. So why not do that? Let's do this one with our calculator. We'll check the mode. And let's see what we get. Let's do inverse sine of 9 second pi divided by 8. Close. Let's close it again. Enter. And we get that ugly answer. If I want the answer in terms of pi, just divide by second pi. Enter. Hit math. Nope, wrong one. Hit math. Enter. Enter. Let me try it again. We have that. Divided by second pi. Math. Enter. Enter. And you see the negative 1/8 and put a pi on top. Now let's do this one. Let's do sine inverse sine of 9 second pi divided by 8. Close. Close. Enter. Error. Domain restriction. See that? Don't be afraid to use the calculator. Inverse cosine, kind of same information. One thing I'm really going to do is look at the graphs to remind you. We're going to graph y equals cosine x. And I'm going to change the mode because it makes it a whole lot easier to see when I do that. To degree. Then we hit zoom 7 for the trig, so you can make it a whole lot easier to see. Remember, this is 0, and then this down here, and this is pi halves, and that's pi, or 90 or 180 degrees, just to show you once again, just as a reminder. So we're going to restrict it from 0 to 180 degrees, or pi. And there it is. So keeping that in mind, that means we're looking at only from 0 to pi, first and second quadrants. So let's find the exact value of inverse cosine of square root 3 over 2. So, if you remember, cosine of square root 3 over 2, that angle is being referred to, let's think about it. I know that sine of 60 is square root 3 over 2. That means that sine of 60 is the same as cosine of 30 degrees. So here's the exact way I'm going to do it. So this is cosine of 30 degrees. So I need the angle such that cosine of 30, or cosine of theta, equals square root 3 over 2. I'm done. Because that means my answer is 30 degrees, because in the first quadrant, cosine is positive, and second it's negative. And so at 30 degrees, you see square 3 over 2. At 150, you see a negative square 3 over 2. We want the positive. And if you just saw what I had, that's the same as pi over 6, because 30 goes 186 times. And then inverse tangent, we're going to restrict the domain. The thing about this is actually incorrect, because it should be parentheses. And the reason why is because that pi halves and negative pi halves, 1 divided by 0 and negative 1 divided by 0 is impossible. So that's the difference between sine and cosine. Sine, the negative pi halves and pi halves exist. In tangent, they do not exist. So be aware of that. And so once again, you can find out by looking at the graph or the unit circle using your trig values how all this works. But I'm going to go ahead and just graph it for you. Graph tangent, that is, just so you can see it as a refresher. Remember, this is negative pi halves and that's pi halves. It doesn't exist there, so we're just looking at it from this portion, which makes it 1 to 1. Once again, restricting the domain, just like we did sine, like we did cosine. We have to restrict the domain. But negative pi halves and pi halves do not exist because we don't get a value there. So we're going to use a calculator to find the inverse tangent of negative square 2 over 5. Before I do that, I'm going to take it back to radian mode. Most of your answers will be in radians. So let's do inverse tangent, and just like sine has an inverse above it, cosine has an inverse above it, tangent does also. Inverse tangent, negative second square root 2, close parentheses, divided by 5, close parentheses, enter, and we get that value. And we're going to round to 2 decimal places once again. 2 decimal places. Negative 0.28. Making sure that the mode is in radians. So the more of these that you do, the more that you're going to realize that it's pretty much looking at the unit circle and making sure you have your domain restrictions correct. Now, we're actually going to find an inverse function. On this example, you're told that the function is negative 2 cosine 3x, where the domain is restricted from 0 to pi thirds. It has to be restricted, otherwise you can't find the inverse. Sometimes you'll be told to restrict it. I think for the most part you'll be told without you having to find it. We're going to find the inverse. We're going to find the range of f and the domain in range of f inverse. Let's go ahead and find the range of f. Now to do so, normally for cosine, the domain is from negative 1. My bad, not the domain. We've already got the domain. Range. The range is from negative 1 to 1. Got that? And that's just for a regular cosine x. But now, if you look at this, remember this negative 2? What it does, it's called the amplitude. It's 2. What it does is, it's going to increase the y values by a factor of 2, by a multiple of 2, we should say. What that means is that we're going to times each one of these by 2 to find the new range, the actual range of our given function. So the range is going to be negative 1 times 2 is negative 2 to 2. So that's that true range of our given function. So this is the range of y equals negative 2 cosine any x, but 3x is fine. The 3 does not affect the range, it only affects the domain, which that's where this 3 came from. For example, it would have been for cosine the range or domain would have been 0 to pi when we restrict it. To get rid of this 3, you divide by 3, and 0 divided by 3 is 0, and pi divided by 3 is pi thirds. That's where that actually came from. And furthermore, we already know the domain of F inverse and the range of F inverse. How do we know that? Well, the domain of F is the same as the range of its inverse. So, that's the problem. I need the correct notation. That just means these interchange. This is the given domain of F. And this is the range of F. So the domain of F inverse is the same as the range of F. So it's going to be negative 2 to 2. And the domain of F inverse is the same as, I should be saying range. The range of F inverse is the same as its domain, which is next between 0 and pi thirds. So let me just clean this up a little bit, make it a little bit easier to see exactly what I'm talking about. Let's just make it a whole lot easier. The notation was getting in my way. Here we go. The domain of F is given to be x between 0 and pi thirds. The range normally would be between negative 1 and 1, but that negative 2, or that 2 I should say, is going to cause the negative 1 and that 1 to be multiplied by 2, so it becomes negative 2 to 2. And once you have the domain range of the function, the inverses, the domain range of the inverses interchange. That's the word I want to use, interchange. So the domain of F inverse is the same as the range of F. And the range of F inverse is the same as the domain of F. So now all we need to find is the actual inverse of the function. So the function is f of x equals negative 2 cosine 3x. Here's the steps. You want to make y, f of x become y. And then the most important step is you want to interchange. That means y becomes x and x becomes y. So we interchanged. X and y. And now we're actually going to solve for y. To do so, we're going to divide both sides by negative 2 first. We get negative x over 2 equals cosine 3y. I need more space. Give me more space. And then we need to get rid of this cosine, so what we're going to use is inverse cosine. Both sides. What do to one side, do to the other. And these like cancel out, leaving 3y equals inverse cosine of negative x over 2. And the last step is to divide both sides by 3. And I'm going to rewrite it as 1/3, because I can pull the 3 out in front with the 1 as the numerator. Inverse cosine of negative x over 2. Instead of using y, I'm going to use the F inverse notation. And that's the answer. Fun, wasn't it? Now let's solve. When we solve, we're going to solve for the inverse function, and then we're going to use inverse function again to help us find the value of x. So here we go. Here's a problem. Here's an example. First thing I want to do is isolate the inverse function. So I'm going to divide both sides by 4. I get inverse sine of x equals pi fourths. The next thing I want to do is take the sine of both sides. These are going to cancel out, leaving the x. And then what is sine of pi fourths? Well, it's 45 degrees. Or, my bad, no it's not. It's the same as sine of 40, same as the sine of 45, which is square root 2 over 2, if you need to. There it is, sine is the y value. And that's it.